Welcome to day 15 of Math 111. Today we're going to be working with addition and subtraction in other bases. This lesson builds upon the previous lesson where we looked at the alien mathematics. Our number system is a positional number system. This means that each digit in a number has a value based on its position within the number. So for instance, if you think of 123, that means that you've got 100, and you've got 2 10s, and you've got 3 1s. Each digit has a meaning depending on its position in the number. Because we have been working with base 10 daily throughout our lives, we're accustomed to it and rarely think too much about place values. We're going to be looking at other systems to help us understand addition and subtraction in base 10 even better. Before we get into the operations, I want to talk a little bit about a term you'll hear me saying. I'll be saying trading up as I talk about some of the manipulations. I will show you in an example what this means. In our manipulative kit associated with operations in various bases, we have 4 objects. We've got a unit, a rod, a flat, and a cube. When we are drawing this on our paper, these are the symbols we will use for these 4 objects. The unit will be represented with a dot, the rod with a vertical line, the flat with a square, and the cube is a square with an angle in the upper left corner. Here you can see some of the objects from the base 4 manipulative kit. In base 4, we trade 4 units for 1 rod. We trade 4 rods for 1 flat. We trade 4 flats for 1 cube. This is what we mean by trading up. We will be doing some examples in base 3 also. Here in the picture you see some of the objects in the base 3 manipulative kit. When we trade up, this is the way it will go. We trade 3 units for 1 rod. We trade 3 rods for 1 flat. And we trade 3 flats for 1 cube. In terms of notation, when you see a subscript on a number, you will know what the base is. So in the example here, we have 121 with the little subscript of 4. This means this number, 121, is a number in base 4. When we are working with addition, we will build both add-ins. When working with the physical manipulatives, you will actually trade up. When you are diagramming the addition on paper, you will show the required trades. I will show you an example of that. Here's an addition problem. 121 base 4 plus 211 base 4. I have both the physical model and the representation as you would draw it. We simply build both add-ins. In the picture on the left, you'll notice at the top of the picture, I've got 1 flat, 2 rods, and 1 unit. That represents the number 121 base 4. At the bottom of that same picture, you'll see 2 flats, 1 rod, and 1 unit. That represents the number 211 base 4. In the illustration on the right, you'll see where I've drawn this. Notice I use the symbols for the flat, the rods, and the unit. When we add, we're just combining. There's no trading necessary in this addition problem. I end up with 3 flats, 3 rods, and 2 units. And this is in base 4. So the sum is represented 332 base 4. Here's another addition problem. 221 base 4 plus 211 base 4. We want to build both addends. After the addends are built, we think about what sort of trades we might need to make. You'll see that you have a total of 2 units. You've got 3 rods and you've got 4 flats. The 4 flats will be traded up for a cube. You'll notice in the picture on the right that I'm in the process of trading the 4 flats for 1 cube. In this picture, you'll see that the flats have been removed and the cube has taken their place. You can now see what the sum is. In the picture on the right, I show how to diagram this. So you begin with the addends. 221 base 4 is represented with 2 flats, 2 rods, and 1 unit. 211 base 4 is represented with 2 flats, 1 rod, and 1 unit. The only trade that needs to be made is the trade for 4 flats trading up to a cube. Notice how that I've circled the 4 flats. I draw the symbol for a cube and draw an arrow to that cube. The sum will be the objects in your drawing that are not in circles. Our sum is 1032 base 4. We have a 0 because there are no flats left. Here's another addition problem in base 4. 221 base 4 plus 213 base 4. Build both addends. Notice I have 2 flats, 2 rods, and 1 unit. And I also have 2 flats, 1 rod, and 3 units. Before I advance the slide, think about what trade needs to be made first. I'll give you a hint. Start with the units. There are 4 units, so 4 units will be traded up for 1 rod. You can see in the picture on the right that I have replaced the 4 units with 1 rod. Notice now that you have 4 rods after making the trade. The 4 rods will be traded up for a flat. In the picture on the right, you'll notice that I have replaced the 4 rods with a flat. There are now 5 flats. 4 of the flats will be traded up for a cube. In the picture on the right, you'll notice that I have traded the 4 flats for a cube. Can you tell what the sum is? You have 1 cube, 1 flat, no rods, and no units. The sum is 1100 base 4. Let's look at this if you were drawing it on paper. Begin with the 2 addends. Draw 221 base 4 and 213 base 4 and begin trading. The 4 units are traded for a rod. We circle the 4 units, draw a rod, and then draw an arrow to that rod. We now have 4 rods. We draw a circle around the 4 rods and draw an arrow to a flat that we draw. Now there are 5 flats. You can circle any 4 of them, whichever 4 you like, and draw a cube. You're trading up for a cube, and draw an arrow to that cube, showing that the 4 flats are being replaced by the cube. The uncircled elements in your drawing represent the sum. The sum is 1100 base 4. Let's look at one in base 3. We have 221 base 3 plus 101 base 3. And again, begin with both addends. Notice in 101 base 3, there is no rod. What kind of trading needs to be done here? Remember, 3 units will be traded up for a rod, 3 rods will be traded up for a flat, 3 flats will be traded up for a cube. If you said that the only trade would be 3 flats or traded up for a cube, you're correct. Notice in the picture on the right that I am replacing the 3 flats with a cube. And in the picture on the right now, you'll see that the cube has taken the place of the 3 flats. Can you tell what the sum is? You have 1 cube, no flats, 2 rods, and 2 units. The sum is 1022 base 3. And here you'll see the drawing on the right where I have started with both addends. I circle the 3 flats because they will be traded up for a cube. I draw the cube and then draw an arrow to the cube I've just drawn. And again, the uncircled elements in your diagram are the sum. The sum is 1022 base 3. Here's a problem in base 5. This is the first one we've seen in base 5. So the trading up goes something like this. 5 units are traded up for a rod. 5 rods are traded up for a flat. 5 flats will be traded up for a cube. We start with both addends. Count the number of units that you have now and think about what the trade will be. There are 7 units. 5 of those units will be traded up for a rod. In the picture on the right, you'll see that I have replaced 5 of the units with a rod. How many rods are in the picture now? There are 8 rods in the picture. 5 of those rods will be traded up for a flat. In the picture on the right, you'll see that I have traded the 5 rods for a flat. There are only 4 flats in our problem. There's no more trading to be done. The sum will be 432 base 5. Let's look at the drawing that you would make on your paper. Again, begin with both addends. You will see where I started with 2, 4, 3 and 1, 3, 4. And again, whenever you're circling for a trade, it doesn't matter which ones you use. Pick the ones that are most convenient for you to draw a circle around. I chose 5 units. They are traded for a rod. So I drew a rod and then drew an arrow to the rod. And 5 rods will be traded for a flat. So I circled 5 rods. I drew a flat and drew an arrow to that flat. The uncircled elements in your diagram make up the sum. There are 4 flats, 3 rods, and 2 units. The sum is 432 base 5. Let's move to subtraction. For subtraction, we may have to trade down. Trading down involves replacing a larger piece with its equivalent in smaller pieces. So for instance, a flat would be replaced with rods. Here's some important information. When working with subtraction, build only the minuend. When we work with the manipulatives, you will physically trade down and take away. When diagramming the subtraction on paper, you will show the required trades. You'll also show that you're taking away pieces by circling them and drawing an arrow to the edge of the page. I will show you that. Here's our first subtraction problem. 221 base 3 minus 111 base 3. Remember to build only the minuend. We build 221 using the items from the base 3 kit. That's 2 flats, 2 rods, and 1 unit. We're subtracting 111 base 3. That means we're taking away 1 flat, 1 rod, and 1 unit. Physically take those away. You're left with 1 flat, 1 rod, and no units. The difference is 110 base 3. You'll see on the right where I've shown the diagram of the subtraction. Again, you start only with the minuend, 221 base 3. We're taking away 111 base 3. You're taking away 1 unit, 1 rod, and 1 flat. Notice that I've circled these and I've drawn arrows to the edge of the page. The uncircled elements make up the difference. The difference is 110 base 3. Here's another subtraction problem. 234 base 4 minus 33 base 4. Build only the minuend. We have 2 flats, 3 rods, and 2 units. Think about what we must take away. We must take away 3 units and 3 rods. We have only 2 units there. In order to take away 3 units, we must trade down. 1 rod will become 4 units. In the picture on the right, you'll see that I've traded a rod for 4 units, and now we're able to take away 3 units. In the picture on the right, you'll notice that I've taken away 3 units. I also have to take away 3 rods. I have only 2 rods there. I will need to trade down again. 1 flat will be traded down for 4 rods. You'll notice in the picture on the right that I have made the trade. I now have 6 rods, and I can take away 3. In the picture on the right, you'll notice that I have taken away 3 rods. The difference is left. I have 1 flat, 3 rods, and 3 units. The difference is 133 base 4. Here, notice that I've drawn the minuend, 232 base 4. I'm going to show you step by step how this is done. The first thing I need to do is take away 3 units. So I'm going to trade down. 1 rod is going to be traded for 4 units. So I circle a rod and I draw my 4 units and draw an arrow from the rod to those units. I'm taking away 3 units, so I circle 3 units and draw an arrow to the edge of the page. It does not matter which ones you circled to take away. The next thing I need to do is take away 3 rods, and there are not 3 rods there. So I trade down again. 1 flat will be traded down for 4 rods. And so notice how I've circled a flat, I've drawn in 4 rods, and I draw an arrow from the circled flat to the 4 rods that I drew. I'm able to take away 3 now, and I can circle any 3 that I want. I will draw an arrow to the edge of the page to show that they're being taken away. The final result, or the difference, is designated with the uncircled elements. You'll notice that I have 1 flat, 3 rods, and 3 units. The difference is 133 base 4. Here I'm showing the comparison between the manipulatives and the drawing. So you can see that I have 133 base 4 in both cases. Here's another subtraction problem. 321 base 4 minus 233 base 4. We start with the minuend. 321 base 4. Since I'm taking away 233 base 4, I'll start with the number of units that I'm taking away. I need to take away 3 units, and there's only 1 unit there. So I will trade down. In the picture on the right, you'll notice that I've traded a rod for 4 units. I'm now able to take away 3 units. In the picture on the right, you'll see that I have taken away the 3 units. I now need to take away 3 rods. There's only 1 rod there. I'm going to trade down again. 1 flat becomes 4 rods, and now I'm able to take away 3 rods. In the picture on the right, you'll see that I've taken away the 3 rods. I'm supposed to take away 2 flats. There are 2 flats there. So in the picture on the right, you'll see that I have taken away the 2 flats. The difference in these 2 numbers in base 4 is 2 base 4. So let's look at how your diagram on your page would develop. You would start with the minuend, 321 base 4. And we think about this the same way as we do with the manipulative. We take away 3 units. We don't have 3 units, so I need to trade down. So in the diagram on the right, you'll notice that I have circled a rod and drawn an arrow to 4 units that I drew. I'm able then to take away 3 units. Next, I need to take away 3 rods, and there are not 3 rods there, so I trade down. I circle one of the flats, draw an arrow to 4 rods that I've drawn. I circle 3 rods and draw an arrow to the edge of the page to show that I'm taking those away. And finally, I want to take away 2 flats. And so I circle the remaining 2 flats and draw an arrow to the edge of the page, showing that they are being taken away. The result is the uncircled elements in your diagram. You have 2 rods and 2 units left. The difference is 2 base 4. Here I showed the results of the manipulative and also the diagram side by side, so you can see the similarities. Sometimes we need to convert these numbers in other bases to base 10. When we do that, it's helpful to create a table. In this problem, I'm converting 2121 base 3 into a base 10 number. In the base 3 number, each position has a value, and these are powers of 3 since we're in base 3. So moving from right to left, the positions have the value 3 to the 0 power, which is 1, 3 to the first power, which equals 3, 3 squared, and then 3 cubed. The digits are 2121 base 3, and I can just fill those in under the appropriate place. And then to convert to base 10, I multiply the digits in my number by the value. So you'll see that I'm multiplying 2 and 27. I'm multiplying 1 and 9. I'm multiplying 2 and 3, and then 1 times 1. I add these products together to get the base 10 number. So I'm adding 54, 9, 6, and 1 to get 70 in base 10. So the number 2121 base 3 is equivalent to 70 in base 10. We can have bases larger than 10. Here's an example from base 12. We only have 10 digits that we use in our numeration system. We can use letters to represent the other 2 digits. So I have my digits 0 through 9, and then I'm using the letter T to represent 10, and E to represent 11. That makes it easy to remember. In other books, you might see A and B being used, or some other character. So this is not standard notation. Here's an addition problem in base 12. 593 base 12 plus 689 base 12. When we trade up in base 12, 12 units become a rod, 12 rods become a flat, and so on. So notice, after I draw both add-ins, I have a total of 12 units. I circle those 12 units, draw a rod, and draw an arrow from the circled units to the rod. I now have 18 rods. 12 rods will be traded up for a flat. I can circle any 12 rods, draw an arrow to a flat that I draw. After drawing that new flat, there are now 12 flats, and the 12 flats will be traded up for a cube. I circle the 12 flats and draw an arrow to the cube that I draw. The uncircled elements in my diagram make the sum. I have 1 cube, 6 rods. I don't have any flats, and I don't have any units left. My sum is 1060 base 12. When we want to convert a base 12 number to base 10, it's really convenient if we make the place value chart. So notice this is very similar to the chart we saw earlier. Our base now is 12, so in the place value row at the top, we'll have 12 to the 0 power, 12 to the first power, 12 to the second power, 12 to the third power. I fill in my digits for my base 12 number, 9E3. To finish my converting, I just multiply. 9 times 144. E, remember, represents 11. So 11 times 12, and 3 times 1. I add these products, 1,296, 132, and 3. The sum is 1,431 base 10. I hope that you have found working in other bases interesting in the lesson today. You need to practice drawing the sum and difference operations as we work with other bases. If you have any questions, be sure to contact me and let me know.